Hello everyone, and welcome back to another GIS lecture video. And in this GIS lecture video, I want to continue our discussion talking about the spatial part of spatial data by diving into this idea of the discrete category of spatial data, which again is just anything that we have a clear definitive boundary for. And we used the examples of roads, we used the example of water bodies, and any sort of political boundary where there was a clear part where you said this starts and this stops, and you could contain everything in a very clear way. So how do we go about actually delineating discrete spatial data using this concept of location? And so the way that we're going to do that is through what's called the vector data model. So discrete data, let me make this a different color, is going to use the vector data model, which is what we're going to talk about in today's video. So let's go ahead and give ourselves a little bit of space here. And we're going to be talking again about the vector data model. All right. So the vector data model is a way of organizing discrete spatial data to be able to represent it using locations. And so basically, the vector data model has three parts. The first part of the vector data model is going to be the coordinates. Let's switch colors here. We don't want to do this in red. The vector data model has three parts. The first part is going to be the coordinates, which we're going to talk a lot about in today's video. The second part is going to be an attribute table, or attributes. And then the third part is going to be a unique ID that relates these coordinates to these attributes so that when we're working with them in any sort of GIS package, we're able to manipulate the coordinates or the attributes and keep them connected together so that we can analyze them separately or bring them together to analyze them together. And that's handled through this unique ID in the back end. So attributes, this is going to be the data. And we're going to talk more about that when we talk about the non-spatial part. So for now, just remember that this exists. What we're going to be focusing on today is this idea of the coordinates, because the coordinates are really the backbone of the vector data model. Right? And so you can think of a vector as a series of coordinates, right? And if we think back to the idea of working with projected locations, so that's where we've taken our latitude and longitude and we've converted them into an X and Y, right? We can think of these largely as being on a Cartesian coordinate system, right? A Cartesian, sorry if I butcher the spelling here, Cartesian coordinate system. Right, where we have the x-axis, we have the y-axis, and then we have the origin. Right. So what the vector data model does is it provides a series of coordinates. And so there are sort of three possible ways that this vector data model can structure itself. Right? The first is to have one coordinate per feature. Right, so this would mean that each discrete feature is being represented by one coordinate. So we'll do this in blue here, right? So for example, we could have the feature ID, which we will call FID. Right, let's say we had 3 features, 1, 2, and 3. Right, for our vector data structure, we're one coordinate per feature. That means that each feature is going to have one coordinate. Right, so this may have a coordinate of 1, 3. This may have a coordinate of 4, 5. And this may have coordinates of, say, 7, 7. Right, and these coordinates here, right, these, just to kind of keep ourselves in track, right, these are the projected coordinates that we talked about in previous lecture series, and we touched on them in a previous video in this series. Right, so we've got locations. If we have one location representing each feature, right, these are said to be points. So to be clear, right, a vector data model where each feature has one coordinate is called a point. Right, and we can graph these. 1, 2, 4, 5, 6, 7. Right, I'm just finishing up this Cartesian coordinate system by adding in the axes. Right, so feature 1 we know is at 1, 3. Right, so this is feature 1. Feature 2 is at 4, 5. 4, 5. Right, we know this is feature 2. And then 3 is at 7, 7. Right, so that's all it means to be a point in the vector data model, is that we have our unique ID here being represented by one coordinate pair. Our next option is to have multiple coordinates per feature. I'm going to slide down just a little bit to give us a little bit of room here. And let's do this one in purple. Right, so in this case, right, we have an FID just like we did before. Right, our unique ID. Let's do 2 here, just to keep it simple. Right, and our chord, right, and this time it's going to be plural because we're having more than one coordinate per feature. Right, so this first feature, right, could be represented by 2, 4, and say 5, 6. And this one could be 0, 0, and 1, 3, and 4, 2. Right? And so what we're going to do here is connect these points together with a line. Right? So the first one here is going to be 2, 4. And then it's going to go to 5, 6. And we're going to connect it with a line, trying not to get into the way of that. Right? And this is our first line Our second one has 3 coordinates. We're going to do the same thing. We're going to go from 0, 0 to 1, 3, which is there, to 4, 2, which is there. Right? And again, we're going to connect them in order. Right? And so when we have multiple coordinates per feature, we call this a line. Okay? If it is exactly 2, it is a true line. If it is more than 2, right, we call this a polyline. Right, because you have multiple lines making up this one feature, right? Because this is a line and this is a line. This whole thing here is called a polyline. Right, so this right here is a line. This whole thing right here, this is a polyline. Right? So hopefully that makes sense. If it's just 2 coordinates, a start point and an end point, it's a true line or a line. If there are more than 2 coordinates, so there's a start point, 1 or more nodes, and then an end point, we call that a polyline. Okay? And then finally, there's one other option, and it's similar to the line, where we have multiple coordinates, per feature. But here's the key part, that form a closed loop. I'm going to underline that in red because that form a closed loop. This is the critical definition piece that separates the line from this piece here. So let's do this one in green. And I'm going to put it over here so we have a little bit extra space. So we have our FID just like before. We have our chords just like before. I'm only going to do one example just because we have a lot more coordinates to deal with. And so for an FID of 1, right, we might have coordinates 5, 5, 7, 6, 4, 3, 2, 5, and then you'll see that it'll go back and close the loop at 5, 5. And so what this is going to do is we're going to start, and we're basically going to trace everything out. So 5, 5 is here, 7, 6 is here, 7, 6 is right here. All right, so we're going to connect those two together. Then 4, 3. All right, we're going to connect those two together. Then 2, 5. We're going to connect those two together. And then you'll see that it actually goes back and ends where it started. Right? The key point here is that this here is the same as this here. Right? That's what causes it to form that closed loop. Right? And so if we have a set of coordinates, multiple features for a coordinate, and they form a closed loop, we call this a polygon. Right? We call this a polygon. And so to recap where we've left off, we have 3 options for vector data. Vector data being a way to represent discrete spatial data using a series of coordinates. If we have just one coordinate per feature, it's called a point. If we have multiple coordinates per feature, it's called a line if it's exactly 2, or a polyline if it's more than 2. And then if those coordinates form a closed loop, meaning the first coordinate and the last coordinate are the same, that is said to be a polygon. So what I want to wrap up this lecture with is just a couple of examples of each type of vector data and where you might find them useful. So let's go ahead and give ourselves just a little bit of room here. So just to recap, we have points, we have lines, and we have polygons. So some examples of point data where you'll commonly see point data referred to. Point data is usually used to capture things like fire hydrants. Right? You might see it used to capture occurrences of vegetation, of invasive species. Right? Generally speaking, anytime you have one coordinate or best representing something as a single location, you're going to use points. Common examples of lines, so you have things like roads, things like rivers, right? Train tracks or train networks. Right? Again, think about your everyday life and things that you would think of as being connected line structures. Those are going to generally be done using the line vector data model. And then finally, polygons are used for things that we would typically think of as having an area. So again, we talked about political boundaries. Right, political boundaries are a big one, right? Counties, states, census tracts, zip codes. Maybe private property is another example. Right. Another big area where we see polygons pop up are when we're dealing with natural disasters, right? When we talk about, oh, we need to evacuate an area, right? We talk about some radius from a given area, right? That's a polygon because it's a circle, right? So evacuation areas, right? These are all examples of things where we would typically be considering them to have an area. Lines are things where we would typically consider them to be a network of things. And then points are going to be things where we're generally just concerned with a single location, or we think of something as having a single point location. So hopefully this made sense. And as always, if you have any questions, please reach out. Thank you.